Okay girls, so today we're going to look at problem solving using trigonometric ratios. Just something that we have to keep in mind, they talk about angle of elevation and angle of depression when we're looking at angles, and they can refer to this in a problem solving question quite frequently, so just you have to know what they're actually talking about. So if we just look at the little kind of image over here, we can see, if you can just imagine this is you standing there and you're looking up at the hot air balloon. So the angle of elevation is the angle that's created from your eye line to the object. So you can see it in here. That's your angle of elevation. And the angle of depression then, if we look at the image down here to the left, is going to be just one that's looking down. So the exact same thing from your eye line to whatever object you're looking down at. So if you're standing at the edge of a cliff and you're looking down, and it's going to be your eye level to you looking down, whatever, if you're looking at a boat in the water or whatever. That's going to be your angle of depression. So a method of measuring these is using a clinometer. So you can hand make clinometers, you can make your own using a protractor, a piece of string and a weight, or people actually buy them. I know if any of you do physics, you're probably familiar with clinometers for measuring angles, but so just to keep that in mind. So what we're going to look at today, so this is the kind of example we're going to look at. I'm actually just going to screen clip it out here and just do it myself so I can talk you through it. And you're going to just do 5 questions on this today, and hopefully you will find them fine. Okay, so obviously if we're using trigonometric ratios to help us with our problem solving, it's because the problem that we're trying to solve is in the shape of a right angle triangle, so just keeping that in mind. Okay, so the Sears Tower in Chicago is one of the world's largest, tallest structures. A tourist wishing to calculate the height of the tower makes measurements shown in the diagram. Using these measurements, calculate the height of the diagram, or of the tower. Okay, so we have, let's get my pen here, we have a person who's standing here, and they're using their clinometer, and they're after figuring out, so they're after measuring the distance they are standing from the highest point of that tower as 202.4 metres, and using their clinometer they've measured, so they've looked from their eye level up to the top of the tower. They found that the angle of elevation was 69 degrees, and what they want us to find, they want to calculate the height of the tower, so that's over this side here, so I'm going to call that x because that's what they want to know. Okay, so you can see the right angle triangle that they've created here for us. The first thing we always do with a right angle triangle is to label it. So let's do so. So we can see this is the right angle here. That's going to be our hypotenuse over here. Our angle is given here 69 degrees, so x is going to be our opposite. And then down here, our distance at the bottom is adjacent. Okay, so we have to figure out what trigonometric ratio we're going to use to help us find the height of that tower. So we know we're obviously going to include opposite in our trigonometric ratio because that's what we want to find. We know that we can only have one unknown, so our angle is we already have identified our unknown, which is x. Our angle is a piece of information we know, and our adjacent is also a piece of information we know. So there are 2 knowns, 1 unknown, so now we can put that into one of our trigonometric ratios and solve. So hypotenuse is not going to be used. So let's recap on what our trigonometric ratios are. So the sine of an angle is O over H. The cosine of an angle is A over H. I hope you all know these at this stage. And the tan of an angle is O over A. So which one of them includes O and A? So it's going to be tan. So we're going to have the tan of 69 degrees is equal to opposite, which was x, over our adjacent, which is 202.4, and we're trying to find x, which is our height. So we want to get x on its own. What is stopping us from getting x on its own? Well, the fact that we have 202.4 divided by x. So let's bring that across, and that will become a multiplier because it's dividing at the minute, so it becomes a multiplier. So we'll have 202.4 tan 69. They're multiplying by each other because they're stuck together, so let's put that in. So in your calculator, 202.4 times tan 69, close your bracket, And that gives us 527.2700 equals x. So let's see what they wanted. Height of the tower. Using these measurements, calculate the height of the tower. Okay, they never said to how many decimal places. In your exam, they always will. We can just say the fact that they've used decimals in the diagram, I'm going to give the answer in decimal form. So the height of the Sears Tower was 527.27 metres. And that's that. So hopefully you understand that. It's quite basic, it's quite simple. I'm going to look at the 5 examples I've given you today just to make sure that you can all do them. So I'll just be scrolling back into the book. Okay, so question 1 is going to be the exact same. I think it's just the Empire State Building. Same idea. Label up your triangle. Figure out which trigonometric ratio you're going to use to find the height of that building. This one here, John is standing on a vertical cliff top. He observes a boat drifting towards the base of the cliff. He measures the angle of depression that he's looking down at as 30 degrees. He knows the cliff top is 200 metres above sea level, so he knows the height of this is 200 metres. And he wants to find out how far away his ship is, or his boat is, or the boat is that he's looking at from the cliff top. Okay, so we can see the triangle, you can see the shape of the triangle that's made here. You can see that 30 degrees does not belong to that triangle. Okay, but you need to be able to use your geometry knowledge, so your alternate angles. So if that angle there is 30 degrees, think of the Z shape. This angle in here is also 30 degrees. So you would have done that in junior cert. So that Z shape there, so the inside of Z shapes are alternate angles and they mean they're the same. So that 30 degrees will also be here. So now in your new triangle that you're looking at, you're going to have your right angle over here by the cliff. By the boat it's 30 degrees. And then you go about solving it. Question 3. A vertical pole is tied to the horizontal ground by means of 2 wires. The longer wire is 22 and so on. So what they want us to find is first the height of the pole. So just focus on the right hand side, right angle triangle, and you'll be able to find the height of that pole. Label your triangle, fill out what trigonometric ratio you're going to use. It's going to be sine really, because your hypotenuse is here and you're trying to find your opposite. And then once you find out what that is, say you found out, I don't know the answer now, say it was 10 metres. Now I don't know what the answer is. It says to the nearest metre. Put your 10 metres there on your diagram and then go about finding the length of the shorter wire. So you're working on the left hand side then. So that's pretty straightforward. That one shouldn't cause too much issues. 2 ships A and B left the harbour. After 2 hours, ship A travelled 46k. So just draw this diagram, fill out all the information you want. So like your 46 goes where ship A is travelled to, so from the harbour to ship A. And then what's the distance by ship B? So you can make a right angle triangle here. You'll know what the distance is here. You want to find the distance here. So again, just using your trigonometric ratios. Find the speed. So how do we find speed? So don't forget your dad's silly triangle. And so distance or speed multiplied by time. So if you want to find speed, it's distance over time. And it tells us 2 hours. So depending, they want it per hour, so you're going to divide by 2. So again, you should be okay on that. Just try your best. Do your best at that one. What's most important at the minute for question 4 is that you're getting part 1 right anyway, that you're able to find or interpret the data to find the distance or one side of the triangle. And then finally, same kind of thing here. With this kind of one, I have to fly through this, there's only 20 seconds left. With this kind of one, you have to remember to take into account Liam's height at the end. Is that okay? Because when you measure the height of this tree from your right angle triangle, you're only getting from 170 metres up, so don't forget to add in the 170 metres. Thanks guys.